Welcome to doassignment-ca. Here is the problem. A particle falls through air with acceleration given by a equals g over vf squared times the quantity vf squared minus v squared, where g is gravitational acceleration and vf is the terminal velocity. The particle starts from rest. Determine the time t needed for the velocity to reach v equals vf divided by 2. Now let us work through the solution step by step. Since acceleration equals dv over dt, we substitute the given formula to get a separable differential equation. We move all velocity terms to the left and the time term to the right. We decompose 1 over vf squared minus v squared using partial fractions, factoring the denominator as vf minus v times vf plus v. This gives 1 over 2 vf times the sum of 1 over vf minus v and 1 over vf plus v. Integrating term by term, the left side becomes 1 over 2 vf times the natural log of the absolute value of the quantity vf plus v divided by vf minus v plus a constant. Integrating the right side gives g over vf squared times t. Plugging in the initial condition that v equals 0 when t equals 0 eliminates the constant, since the log of 1 is 0. Multiplying both sides by 2vf and then solving for t gives t equals vf over 2g times the natural log of the quantity vf plus v divided by vf minus v. Substituting v equals vf over 2, the numerator inside the log becomes 3/2 vf and the denominator becomes 1/2 vf, giving a ratio of exactly 3, so the expression simplifies to vf over 2g times the natural log of 3. The final answer is t equals vf divided by 2g times the natural log of 3. Numerically, since the natural log of 3 is about 1.099, this equals approximately 0.549 times vf over g. This is physically consistent. A larger terminal velocity or smaller gravitational acceleration both require more time to reach half the terminal speed. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.